polygon tool, right? And then I can extrude this polygon into a solid. And in Maya, there's a tool here is polygon edge to curve. I think I covered a long time ago is you can convert NURB to polygon, but you cannot convert polygon to NURB directly. Here is actually something in between. You can convert a polygon edge directly into a curve. This could be really useful. You can maintain the curve as one linear, then you can pick up the edge. So here I can select edges to pick up this edge, holding shift. So for example, I select these edges and hit apply. So basically what happened is you see a new curve show up. If I move up, this is directly come from that polygon, okay? So this is a trick I think really useful if the tower you create is based on the polygonal shape. You know, you have a sequence of polygon, you animate, you create a shape, right? And later the question is how you can create a skin from that polygon mesh. If you can pick up particular edges, convert to this curve, and later this curve will animate with the polygon, then you can use that to build up the skin. Okay, I'm not sure if that makes sense. See here, if I give 300 frames, and in the first frame, for example, if I animate this one, in the last frame, I will move up and rotate a little bit. So now if I play, you'll see this polygon go with it. And this curve will always follow that polygon, right? Because this curve is converted from that polygon. So that means I can basically create animation snapshot based on that curve. So you get a sequence of curve. Or I can base on this polygon. So either one. And this polygon curve, I can easily create a loft. So surface, loft. So you can get something like a skin. That makes sense? So even the animations originally come from the polygon, you can still make the surface. Right? So I think that's what I'm trying to say. Another technique I want to talk really quick is about use the motion path, which is pretty simple. If you have a curve, let's do that in the front view. If I draw another curve, right? So you have two curves, right? And then I can draw another curve. All right, then I draw the third one. For this curve, I will select the control points. So this is control points. Well, actually, let me redo this curve as a linear. The difference is linear curve only has 2 points, right? One is the front, another is the end. So that's the 2 points. For these points, I'm going to create a cluster. So create deformers, create a cluster. And then I'm going to attach, let me make sure this cluster is right here. Actually, I have to redo this. Control vertex, create a cluster. So basically what happened is now if I move my cluster, this point is going to move with the cluster, right? So you can select the cluster, select this curve, So cluster first, then the curve. Then I can make animation along the motion path. Okay, attached to motion path. Now if I play animation, see what happens. This cluster is going to follow that curve. Right? Now I can pick up the second control vertex. I'm going to create the second cluster right here. And select the second cluster on this line. I'm going to create another motion path. So now if I play, you'll see this line is always between these two curves. Pretty cool. So this could be a really interesting way. For example, I want to design a bridge. Right? So here is that line. I'm going to create animation snapshot. Let's do a higher density. So what happened is you got a sequence of lines in between. Very nice. All right. So that's something you definitely can easily do with Maya. Also, if you run the Mel script, remember the one I showed you a long time ago. I think it's this one. The Mel script, you can generate a cylinder, right, based on a curve. So that is that cylinder shape. Let's make this one smaller. So if I play the animation, you see that guy is go with it. Then I can create animation snapshot. So that is all the details you can build. I can also build up this line, pick up this line as well, run the script. Then for that guy, I will scale. Very nice. You got the whole geometries, right? Easily created in Maya with animation. And the benefit is in the future, if you do want to, let's move this guy here. Right, this is the original curve. So in the future, I think, well, I'm not happy with the curve. I can select the curve. I can reshape the curve. Right, so I shape the curve like this. All right, and after that, I'm going to update the two snapshot. So update motion, where is that? Snapshot. So it's recalculate. Everything is correct. Very cool. So this is the motion path. Hopefully that could help you a little bit for this homework. All right, so the focus of today actually is about rendering. So I will talk really quick about Maya render. It's not really the focus of this course, but I think it's good you know that how to do the good-looking images in Maya. So the homework will look better. I will just create a bunch of ball here. All right, then I'm going to make a rendering. In Maya, by default, if you go to render, this is the render setting toolbar. You can click these render settings. By default, Maya software is the default rendering engine. If you want to know detail of this rendering, you can go to lynda.com. There's many tutorials about that. Besides Maya software, you can do Mental Ray as well. In Revit, is used Mental Ray as rendering engine. It's a global illumination engine which calculate bouncing light. It's more realistic. So today I'm going to talk about Mental Ray rendering. It's a little bit slower compared with Maya software, but the result is better. So I use Mental Ray. One thing, if you don't see Mental Ray options here, you probably have to go back to your window, settings, plugin manager, because Mental Ray in Maya is a plugin. So in Plugin Manager, make sure you check Maya to MR. So this guy, Maya to MR, means MR means mental ray. So by default, it should be turned on. Just in case, if it's not on, you have to check. So you can see that option right here, mental ray. If you choose mental ray, there's many options here. I will just talk really quick how to set up the basic sunlight and skylight, which is in the indirect lighting tag. So here you can create a physical sun and sky, just one single click. All right, so you create a sky. And if you look at the outline in your scene, there's no much difference, except you'll see a lighting object right here, sun direct light. I can use R to scale, just to make this light a little bit bigger so you can see it. All right, so that is the direction light. Rotate a little bit. Scale that a little bit. Okay. Then I can make a rendering. Just one click the render button here. It should generate a rendering in a few seconds. Okay. Well, there's something wrong with my computer. I mean, compare with Revit, you can see the mental ray rendering in Maya is super fast. And the quality is really nice, right? If you do the same rendering in Revit, it would take about 10-15 minutes. But here is less than 1 minute. Super fast. That's the reason I highly recommend. If you do have geometries, you can definitely transfer your model from Revit to Maya or Max, which works much better. All right. Also, one thing is about the light is relate with the angle. So if the light is really lower angle like this, it's more like a sunset. Now if I render, Maya will figure out the color of the sky, the intensity of the sky directly relate with the angle. So if the angle is very low, that's the rendering effects you have. All right, very cool. So it's all dynamic related. If you want to render, let's see, 12 o'clock, so that's what the light looks like. Do the same rendering. You can see the sky is bright and exposure is very high. That makes sense? It's related with the sun, related with the light. Okay? So that's about rendering light. Another thing you want to pay attention is about resolution. In the comment tag, here the image format, usually I will suggest TIFF. This is good file format and compression. Preset is the resolution, but you can do as high as you want. You can do, let's see, 2000. This is actually pretty high, 1500, high resolution. Now if I do the same rendering, it will take a lot of actual calculation, right? Longer time to render. But when you print, it will be a better quality. You can do a larger scale print. See, now you can definitely feel that is taking a longer time. Is that right? So higher resolution. One thing about the global illumination I have to highlight is if you look at the bouncing light, something in the shadow. Although this part of the the ground is not directly exposed to the sun, but you still get the lighting, right? Because the lighting will bouncing from the different directions. That is the beauty about global illumination. So here, if I do a 1 by 1, this is actually the true resolution, 1 by 1. After you finish the rendering, you can go to File, you can save that image, right? You can save the image as TIFF or JPEG. I think TIFF definitely is much better. Okay? And then you can bring into Photoshop. That's about rendering. That's it. Pretty quick, right? 5 minutes. Questions related with rendering? All right. I will talk really quick about material. Like right now, everything is a white plastic. how can I control the material? First, I will make the sphere with a new material. So right-click. You can assign a new material. So right-click, use a drop-down, a pop-up menu, choose Assign New Material. So you got these options. In Maya, if you want to simulate something like a highly polished metal or glass, you use Blend. Either Blend or Fawn, they all works. These two shader has reflectivities, right? So when I mention shader in Maya, that means material. Okay, material equals shader. Just keep that in mind. So now if I choose Blend, it has this kind of reflective material. It also automatically pop up this attribute editor. I can define a color. Let's give kind of purple color here. So that's a color controlled. You can also control the transparency, make it transparent. You can see the result. I will just keep this as a purple and then do a rendering. Let's see. I don't want to have a high resolution. It's too slow. Let's do a 600, 400. So now if I render, you should see this purple color sphere has all the reflectivities. Very cool, right? It reflects the environment. The same thing, I can do another one for the ground. So for the ground, select, right-click, assign new material. For this one, since I want this to be reflective, I will use Blend as well. I will make the color pretty dark. Okay. Then let's render. Okay. You see reflections right there. Right. I think the sun angle is a little bit too high. That's the reason it's getting pretty hot. So let's just lower the angle a little bit. This will looks better. So in my rendering, you have to try, play with the different angles, intensities, until you get something you really like. So here is a nice reflections. All right, what if I want something not reflective? In that case, you will assign a new material. I will use Lambert, L-A-M-B-E-R-T, Lambert. Lambert is a material you can simulate like a rock, stone, bricks, soils, which don't have any reflectivities, right? So Lambert. Again, I can choose a color. Let's see, green color here. Right? And if you look at this attribute, you don't have that reflectivities control. So if I render, there's no reflections. See, on the ground is a solid color. That makes sense? So Blend, Lambert, and Fawn, the three shaders, they have a different property. There's one more shader I want to show you. It's actually pretty fun. Assign new material. Besides this default, you can assign the ocean shader. Because sometimes I know you guys want to do water or something. So ocean shader is a quick way. You can simulate the water, which you can control, for example, the scale. You can control the wave. You can control many colors, many stuff. I will just keep this as a default, do a rendering. And later you can definitely dig out to find more details. This shader actually has animation. If you render as a video file, you can see the water is actually moving very nicely. All right, so this is how you can simulate water here in Maya. Again, you see it's taking a longer time, right? But it's not too bad. All right, three shaders. The next thing is about how you can assign the actual geometry, the patterns on the surface. This has to be done through this window in the render hypershade. What I mean the texture is, the texture could be a two-dimension image, like bricks, wood. You use that image to assign to the shader. In this homework, you don't have to do anything related with texture, but in the future, maybe you will. So here I want to show you in the hypershade window. let's take a look at what is the default shader I just create. So here, there's a bunch of shaders, right? You can see the purple one I just create. This is the ocean. Actually, this is the ocean shader. So each shader, if you right-click, you can choose a graph network. It actually will show you how the shader was built. Okay. So for example, this green one, I can use middle button, drag and drop. This is the way you can drag and drop the shader to a geometry. Drag and drop. Okay. However, this shader is kind of like a solid. There's no patterns, no image associated. So next thing I will show you how to attach an image. Double click this shader. In the color channel, I can click this check. Again, this is available in lynda.com, so I will go through really quick. So color channel, click the checker. Then I can define a file to attach to the checker. All right, so I will check file. I will link an image. I don't have really interesting image. Let me just Google one. What do you want? Break, maybe? How about this? Actually, I don't really concern too much. So save the image in desktop, JPEG, okay. Then back to Maya. I'm going to pick up this guy. Click OK. So basically, you defined a target for this shader. Now, if I refresh the network, you can see that break image is attached to number 2, right? If I look at the scene, I can use a hotkey, I think it's number 6, to turn on the shader display. Number 6. So you can actually see the shader right there. If you think, well, this break is good, but the scale is too big, right? In that case, I can double click this place 2D. This is a controller, control the scale. So in the place 2D node, you can control how many times you want to repeat U and V. So let's give 5 by 5. Let's see what happened. You got a smaller break. This is exactly the same in 3D Studio Max. So go here, place 2D. Then you can control how many times. 2 by 2. You'll see the scale change. Okay? So this is how you control the scale. You can also drag the same texture with middle button and drop to the shader. When you drop, you can choose another connection, let's see, bump. So you can see the same image control both the color channel as well as the bump channel. Now, if you click the shader, you see the shader has a color channel right here. It has a bump channel right here, right? They all controlled by this image. For bump, I can define the height of the bump. And I'm going to make a rendering. I think it will make more sense if I do a rendering. So here's the bump effects. So bump is actually a way you can simulate a 3D effects based on the 2D image. Right? All the white part is pushed up. The black or dark gray is pushed down. So you get a really rough, surface like that. Okay, so this is good. I think that's the reason why I really like use Maya to do rendering. I mean, if you do the same thing in other program, like in Revit, it will take a long time. Is that right? So here, see how quick you can get these effects. Really fast. And if you need something transparent, I think we already covered. Let's go back to this render hypershade. For example, I want this purple sphere be transparent. So double click this shader. I'll make the transparent, drag the bar. Can you see the transparency here? Right, if you render that, it'll be transparent. Okay, so that's all about, oh, there's one more thing. Let's cancel that. Another quick way to assign material to a geometry is if you pre-select the geometry from here. In the hypershade, you can right-click the shader and choose Assign Material to Selection. So you don't have to drag them one by one. See? I can just right-click, Assign Material to Selection. That's a quick way. I will assign to the ocean shader. Okay. I think that's it. This is all about material and texture. Again, if you want to dig into detail, you must take a look at lynda.com. There's tons of tutorials there. Talk about materials. I think the one I introduced today should be good enough for you to finish the midterm project. Good question. Yes, you can create additional cameras if you like. So here, you can create more cameras. And after you create a new camera one, you can go to Show, actually not Show. You can go to Panels, Perspective. You can see camera one you just create. So basically, you are look through the camera one. You can tell from this name here, camera one. Right, so you can set up as many as you want. One suggestion is, it's good you set up camera first and then set up the mental ray. And then set up the mental ray sunlight. The reason is the sunlight is always associated with a camera. If you have a camera set up first, that sun will associate with this camera. Right, so do the camera first and then set up the sun. All right. Any other questions? Oh, about camera's feature, I think it's good to cover. See, if I use Control A, I can open attribute panel of camera. Actually, in Maya, if you use Control A, you can open any attribute panels from your selection. So here's the attribute panel of camera. I don't think this will be something difficult to understand. You can dynamically change these values like view angles, focal length. You can change the clipping plan. Okay, basically I think view angle will be something we want to play with. What is the angle for human eye? Say again? Oh, no, I mean angle, not height. How many degrees? 55. All right. Average. So that's a view angle. If you have really wide angle, this is like a fish eye, right? And also you can make it really low, this is a bird. So that's a different animals here, right? Okay, that's about the camera. Questions so far, good? Okay, I think they all somehow really helpful for you to do the rendering. We have 20 minutes, so I will talk really quick about transfer Maya to Rhino. Then you can do the, some stuff there. To make things easier, I will just create a simple, really simple geometry. Let's see. Maybe just a curve. I want this to be more interesting. Let's delete that. I would do a 3 cubic. Then for this surface, I'm going to close the curve. Okay, as the curve looks like. If I look at control points, that's all the control points. I'm actually going to rebuild the curve. 40 points, that's okay. So click OK, nothing too much. Let's give 20. Now if I look at control points, it's very even. All right, so rebuild curve is always helpful. Let's give 300 frames. At the beginning, I use S. At the end, move up. Yeah, sorry I did this super fast, but you guys already know how to do it, right? So rotate a little bit. S. Now if I play, that's animation. Maybe at the end I want to make it bigger. S. Okay. And then go to animation and create animation snapshot. Let's see. I think every 10 frames should be good. So that's a shape. And then I will do a loft, right? So here we go. And all right. So this is the shape I made for Maya. I'm going to transfer to Rhino and to do something there. All right. Select, export selection. Let's see what file format I should use to transfer to Rhino. If you're doing anything related with NURB surface, the first choice actually is not available here, is IGES, which I don't see it. Let's cancel. Go to plugin manager. I think I didn't check this option. See, IGES. IGES is a special file format you can read from Rhino. Really clean, IGES. So now if I export the selection, I should get this option now. See, IGES. So I will make the file here on my desktop, give this name Tower Maya. All right, I'm done. Then I go back to, this is Rhino. How many of you use Rhino here? Pretty much everyone? No? Okay. Rhino is a really good tool if you do anything related with laser card. See here, I can easily import that IGES file from Maya, which is Tower Maya, right? The seed file is actually pretty tiny, 61K. Here we go, and then I will just zoom out. Here we go. That's a Maya model in Rhino. Pretty cool. You see something happen, right? The top view is actually the side view, because in Maya is Y up, in Rhino is Z up. So what you need to do is rotate. (90 degrees). Here we go. So this is a Maya model in Rhino. So here's a couple questions. Why you want to do this in Rhino? What's the benefit? First, there are a couple of tools I think is really useful. The first one is a CAP, C-A-P. It's automatically close the surface for you. So you got this as a mass. Right, really cool. You can send this to laser card to the 3D print, the entire model. You can 3D print. Okay. Another really cool feature I like a lot in Rhino is contour. C-O-N-T-O-U-R, contour. So you can pick up object, enter. I can select axis. I can define the distance. Let's give 5 here. Let's control the entire model. This is all the lines. All right. So this line is not necessary follow the ISO curve. I mean, it's horizontal. Then you can do what? planar surf. Select all the lines, enter finish. What happened? All the plans. Okay, planar surf. And then what? Extrude surf. Pick up all the line. Well, this is something. Actually, let's cancel first. Because here's the problem. You see, let's undo first. This is all the lines, right? When I do the planar surf, what happened is Rhino will generate all the planars. However, all the original curve are still in that location. So they overlapped with the planar. What I have to do is, this is actually pretty tricky. In select object, I will select all the surfaces. Holding shift, I move the surface a little bit. So you can see both the surface and the original curve. You don't want them overlap with each other, because this will be a trouble in the future. Just make sure anytime you generate new objects, you want to move that new objects away from the original object. Make sense? They don't kind of collapse in the same place. The same thing here. If I do extrude surf, I pick up this, enter, and then it will extrude every single planar in z-axis. Let's give the height to, I don't know, maybe 1. So you all got the thickness, right? Oh, actually, let's undo that. Extrude surf one more time. Which I forgot to do is, in the options, you can choose a cap equals yes. So it automatically encloses the cap. Okay, so this is something you wanna do. The height, I think 1 should be okay. So now you see all of this solid floor plan. But I'm not sure if the original, yeah, I see the original surface are still here. So this is actually a little bit annoying. It's better to do this by layer. I should do that in the first place, but anyway. So here I'm going to choose all the surfaces and move that away. Okay, so this, why is this guy here? So this is all the surface, this is all the solid model. Pretty cool. All right, so the question is, can I laser cut this and assemble them together? The answer is yes and no. I mean, if you want to just glue them one by one, you can do it. But before you glue them, usually I would suggest you design something like the elevator, like a concrete core for the elevator. Which one is the? Yeah, that one is. Because you do want to assemble this together, right? A quick way to do that is just, I will create a solid box, like my concrete elevator. I will make it penetrate all the floors. Maybe it's a little bit too big, but you got the idea, right? And then what I'm going to do is boolean subtract. So pick up all the geometries, all the geometries for the floor, enter finish, and pick up elevator, enter finish. Cool. So every single laser cut layer, you got this shape. This shape will help you make alignment for this particular panel. That makes sense? You can use a square to help you to kind of, as an anchor point, to lay down all the layers. But it's not finished yet. I mean, there's many ways you can actually, let's undo that first. There are many ways you can create kind of like a snapping point. in some situation, maybe you can create that new structures not necessarily through subtract. You can do something with union. So for example, if you design something like a corridor, probably I want this one be a little bit lower. All right, probably we're missing the first one. I'll just delete that. So you got an idea. So maybe the tower is like that shape, you know, right? So in this case, I can do a union. And then I can unify this as one object. So there are many, many ways so you can get this as one single geometry. So there's many ways you can do the laser cut. It's really up to you. You think about. For me, I think probably it will make more sense just subtract something in the middle. Okay, this time I will do something kind of different because I don't want to repeat things. All right, then I will do a subtract, pick up geometries, except this one, enter finish. So this is the first group. Second group is this guy. So this is the result. All right, so each layer has this kind of void only on one side. And the question is how we can laser cut this, right? Is there any of you use Grasshopper, Rhino script? 1, 2, 3, 4, 5, okay. It's a script. I will show you really quick. Grasshopper. Oh, there's something wrong with my Rhino. Well, I will show you next class because today is a little bit too late. In Grasshopper script, you can automatically lay out these laser cut patterns. If you don't have that script, you have to do this manually. So that means if you select the first one, drag it here, second one, you have to do this one by one, which for me is okay. Depends on how many, layers you have. All right, to save some time, I will just pick up a few. So ideally, you want to move these individual levels, make a good alignment on this side. So this is all ready for laser cut. Then I can use a command named make 2D. Select this object, enter, then check show tangent edges, click OK. It automatically converts all the solid 3D objects into 2D patterns. If I look at it in 3D, this is all 2 dimension. Original one is 3 dimension. You see the difference? Okay. So this one is much cleaner. It does not have this weird lines in between. This one is super clean. Right? Then you can export these lines, export selection into DXF. Then you're ready for laser cut. That makes sense? So this is the whole sequence, how you can transfer Maya model to Rhino, do all the contour lines. Just make sure you design the joints, elevator shelf or whatever stuff. You can assemble this later. Then you can transfer to laser cut. There are so many different ways you can assemble the model. It's really up to you. I think in some case, for example, in this geometry, right, you can also customize some detail. For example, I can create I don't know what would be the best way. Maybe here. Right, you can create additional details like that. And then you can make subtract. Pick up this guy first. I don't want to delete input, so make sure you check delete input as no. Then I can pick up all the lines here, enter finish. Now you get this nice, I don't know, it's more like a guideline, right? And each piece here, you can use that as a notch to slice in. That makes sense? Because all the planners is going to slice right inside these notches. So the notches, you see the location of these notches. And this is a plan. Now you know the relation, right? Between these two. But I think this will be an issue, right? It's hard to fit this in. Is that right? You cannot really fit this in. So this is the problem. But if this notches is on this side, it could work. Or maybe on this side. Yeah, I think this will work. I'm going to do a rotate, because the dimension is kind of the same. So here, rotate. Pick up this guy.